Measurement resolution is the third R of precision. Resolution deals with using the right tool for the right job. Typically, the 10 bucket rule is used for resolution, meaning your measurement tool must go one decimal place further than what you're trying to measure so that you can round properly. There are different types of measurement errors associated with all of this variability. So process variability versus measurement system variability. There are standard acceptable levels for the amount of variation within your measurement system versus the total variation within the study. Again, you can see accuracy versus precision on the left. We'll do crossed MSAs versus nested MSAs for non-destructive testing. This consists of multiple appraisers, multiple trials, but the same parts. The idea of starting with appraiser 1 and measuring all 6 parts in random order helps to eliminate bias. If we follow that same process and mix the order up for appraiser 2, then appraiser 3, that eliminates bias as well. We then go back and measure appraiser 1 doing the exact same thing, then 2 and 3. What that does is help with the repeatability aspect of the MSA. Here's the data. You can clearly see that operator 1 did all 6 measurements, not in 1 through 6 order, but did all 6 measurements. Then operator 2 did all 6 measurements in random order, then 3, then we went back to 1 and repeated the process. Here is the output from Minitab for the gauge R&R. We'll go a little bit more in depth into the run charts for both the range and the X bar, but you can clearly see that on the bottom left, operator 1 for part 1 is quite out of control, we would say. Also on the right, you'll see in the middle, it's a box and whisker plot where we're comparing operator 1 for the 3 different trials that they did, and we'll talk more about the anatomy of a box and whisker plot later in this course. Here are the number outputs. One thing I'd like to point out is the source. So what source is adding variation to this process? Is it the repeatability piece where operators agree with themselves, the reproducibility piece where operators agree with each other, or is it part-to-part variation? What we really want is part-to-part variation to make up the bulk of the variation or contribution of the variation so that we get data that we can rely on. Again, here are the numbers with the percent contribution in a little bit cleaner chart. And here's the summary. Again, what we're looking for is the measurement system to provide the minimum amount of variation to our process. Non-destructive testing is where operator 3 can measure the exact same part as operator 1 and 2 did. Destructive testing is where once the sample is taken or the observation is taken, they can no longer measure that particular item again. Now if we talk about attribute data, we can also do MSAs on attribute data. Attribute data requires more samples because you only have a limited amount of options. One of the good things about attribute MSAs is that we know what the real number is or what the true value is. Therefore, we can compare our appraisers to that true value. It's something we cannot do in the measurement, in the variable MSA.